Here we have question 6 on an AP chemistry exam, as question number 6 is one of the short 4-pointers. When I first read this, trying to pretend I was a student taking this exam, I read it and this one really had me stumped. Let me read the question. We've got a table, that made sense, lithium iodide, potassium iodide, ionic compounds, and they've got their melting temperature. Now let's read the question. A student learns that ionic compounds have significant covalent character when a cation has a polarizing effect on a large anion. As a result, the student hypothesizes that salts composed of small cations and large anions would have relatively low melting temperatures. Now, I've been teaching quite a few years, and I know the AP curriculum backwards and forwards. I even know the previous AP Chem curriculum, the pre-2014. And I said, polarizing effect on large anions, covalent characters of ionic compounds. I've never heard of that. Why are they asking this? This was a real head scratcher for me. And as a result, I said, I don't like this question. But then I worked on it for a while, and now it's one of my favorite questions. Let me explain why. Let's read this over again and see. As a result, the student hypothesized that salts composed of small cations. Well, I know what cations are. Lithium, potassium, lithium, sodium. Okay, there's only 3 cations. And large anions. The anions are only iodine and fluorine. Okay, it's getting simpler now. Should have relatively low melting temperatures. Okay, I sort of understand that. Select 2 compounds from the table and explain how the data supports the student's hypothesis. Like I said, we've covered AP Chem curriculum. You know everything here. Everything that you need to answer the question. It says select 2 compounds from the table. Now they said compounds with small cations and large anions have relatively low melting temperatures. Well, okay, I hope you remember atomic sizes. And that's one of the critical things we've learned. Here's one of our study cards where we've got study cards 64 and 65 out of 200, where we talk about atomic size. You're going to use this table on the AP exam many times. As you go down the periodic table, atomic size increases. That's really going to be very helpful on this question. So let's go back to the question. Select 2 compounds and explain data that supports the hypothesis. Well, we need a compound that has small cations. Well, remember our table here, small cations. Here's our positively charged ions, so we need something that's lithium. So we're going to have a compound with lithium in it. And there's 2 of them here. There's lithium iodide and lithium fluoride. And look, one has a large anion, iodide ions. We remember again from our periodic table where iodine is, and one with a small anion, and that's what they're talking about. So those are the 2 to select. We pick a lithium fluoride, small cation, small anion. That's what they were testing. They were testing to see if you knew about the sizes of atoms. Lithium iodide, small cation, large anion. Now the hypothesis is that this small cation, large anion, should have a low melting temperature. Guess what they gave us? Melting temperatures. Let's look at those melting temperatures. Lithium fluoride, small cation, small anion, 845. And lithium iodide, the small cation, large anion, 449. That's the hypothesis. If you got a large anion, you got a low melting temperature, and we just proved it. We've answered the question. The data supports the claim that small cation, large anions have low melting temperatures. That's all you had to show. 2 points for this. 1 point for comparing any small cation, small anion, small cation, large anion. So that's it. You got 1 point for just saying LIF, LII. And then that's the combinations they're talking about. And then showing data that confirms the hypothesis. You didn't have to worry about polarizing effects in anions. All they wanted was select 2 compounds, which they listed here, which you know, and explain how the data supports the student hypothesis, low melting temperatures. You didn't have to learn anything that was exotic. This really wasn't a head scratcher. It was just a matter of reading the question. When you run into a problem like this, don't say, oh, I can't answer it. Read it over again and look for the parts that you recognize. You know cation, you know anion, you know small, you know large, and they gave you the melting temperatures. That's all you had to know. This is why it's not one of my favorite questions, because it didn't require all that much. So that's A, 2 points out of our possible 4. And we didn't have to write a lot. Next, B. Identify a compound from the table that can be dissolved in water to produce a basic solution. Okay, we've got to identify something. And then write the net ionic equation for the reaction to cause the solution to be basic. First of all, let's look at the table. These 4 possible compounds that can be dissolved in water to produce a basic solution. We're going to dissolve this in water to hydrolyze it to make a base. Water reacting to make a base because it's dissolving to make a basic solution, to make some hydroxide. So we know whatever's going to be reacting with water is going to have a negative charge because we've got a negative charge product here. So we know it's either going to be iodide or fluoride. And then, of course, the question is, which one of those is it going to be? If we have iodide reacting with water, we would have HI and OH minus. All right, our charges are conserved. And if fluoride reacted with water, we would have fluoride reacting with H2O to make HF, and hydroxide, a basic solution. Which one is it going to be? Well, we know both of those anions originally came from an acid, HI, which is one of the strong acids that you know, and HF, which is one of the weak acids. In fact, we've done problems with hydrofluoric acid before. So this is a weak acid, so it produces a weak conjugate base. This, just like HCl, chloride doesn't do anything, iodide doesn't do anything, nitrate doesn't do anything. Any anion of a strong acid does nothing. So that gets rid of this. We don't have to worry about iodide. We just have to pick a compound with fluoride in it, either lithium fluoride or sodium fluoride. Either one's fine. Either one of those is acceptable. Now, if you couldn't get through that reasoning, one extra hint, it says identify a compound from the table that can be dissolved with water to make a basic solution. Even if you didn't have time or couldn't figure out, pick one of these. Use your pencil, spin it around, say, okay, it's this one. You had a 50-50 chance of getting this point if you picked lithium fluoride or sodium fluoride. They would have given you a point, period. That's 1 point. So one of the rules is answer all the questions, even if you're guessing. When they give you a choice, pick something no matter what. Now, we know it's going to be fluoride. And a net ionic reaction would be that fluoride reacting with water. The fluoride sticks to this H and gives us HF. This is a molecular substance that's going to stick together. And this is OH minus, our base. And then we get 1 point for that balanced reaction. The fluoride ion is charged. Hydroxide's our base that we made. Identify a compound. We picked one. 50-50 chance, but we picked the right one. And then write a net ionic equation that shows what's happening. Now, thinking about this, 2 points here. Pretty easy. I think this last question was a bit tough, but again, you had a 50-50 chance. That would give you 3 out of 4. With 2 out of 4 even, though, you get a passing grade on the AP exam and get a little bit of perspective. Of all the students in the U.S. that can take AP chemistry, 5 out of 100 take AP chemistry. So you're already in the top 5% being in the class. And then passing it puts you in the top 2%. That's just getting a 3. That puts you in a very elite group. One of the reasons colleges really appreciate AP Chem on a resume is because they know students have gone beyond to try and learn more. So it'll be nice to get a great score, but just getting this far, kudos. You're great.
By the way, we only spent about 9 minutes on this question, and you're allotted 10, so we were able to explain and answer within the time limit. Bottom line of this question, even though when you find something that looks like totally difficult to do and impossible, read it over again. Here, it said just select 2 compounds and select some data. That's what it was, and we were able to do it. So, you can go on to the next questions with some confidence.